Okay, so quick review of the mole. Okay, remember that a mole measures the amount of something. Okay, but a mole represents a number of particles. Okay, so if I have a mole of calcium, I will have 6.02 times 10 to the 23 atoms of calcium. Okay. If I have 1 mole of water, I will have 6.02 times 10 to the 23 molecules of water. Okay, it represents the number of particles, represents that number of particles of whatever substance it is you are dealing with. Everybody follow me there. Okay, so that's what 1 mole represents. So if I have 2 moles of something, I have 2 times this number. Okay, in the same way that if I have 2 dozen donuts, I have 2 times 12 donuts. Okay, if I have 2 moles of something, I have 2 times this number of it. Everybody follow there? Okay, so it's really important that we get that Avogadro's number, this number, applies to everything universally. Okay, in the same way that if I have a dozen oranges, a dozen apples, a dozen donuts, a dozen eggs, it's always 12. Okay, it doesn't matter what I apply it to, that number represents, or that word represents always 12. Okay, this number is always 1 mole. It doesn't matter what I'm dealing with. Okay, so there are 4 ways that I can ask a mole equation problem. Remember that the mole equation is this. N, which is the number of moles, equals little m, which is mass in grams, divided by big M, which is molar mass, the mass of 1 mole of that material in grams. Okay. Is that ringing a bell from last week? Okay. Now, these questions here are a little bit easier than what I would ask on an exam. Here's why they're a little bit easier. I gave you the formulas for all of the materials. On a test, I would not. I would give you the names instead, and there would be that extra step of seeing whether you can get the proper formula from the name. Okay, but just for today, just for concentrating on one thing at a time, okay, we're going to look at solving them this way. So we'll start with number 1, which is the easiest of the 4 mole equation types. Okay. All right, so how many moles of calcium carbonate are in 125 grams? First thing we want to do in any problem-solving situation, be it mole equation or when we get to physics, okay, the first step is write down your givens. That is what the question told you. So the question told me the material, calcium carbonate, which means I can calculate the molar mass using the periodic table. All right, so I'm going to have 40.08, because that's the molar mass of calcium. Only 1 calcium here. Okay, how many carbons are there? 1. Okay, so plus 12.01, plus there are 3 oxygens. Okay, so that'll get me the molar mass. Okay, so we got 40.08. All right, so we got 40.08, okay, plus 12.01 plus 48. That's 16 times 3. Oh. Okay, so we got 100.09 grams per mole. So that's the mass of 1 mole. Okay, or the mass of 6.02 times 10 to the 23 particles, molecules of calcium carbonate. All right, so I've got that. The question wants to know how many moles there are. So it's asking me to calculate N. And it also tells me the mass in grams, 125 grams. Okay, so if this was an exam or a quiz, you'd get a mark for that. Okay, effectively that's your givens in calculating the molar mass. Now, the mole equation is already set up to calculate the number of moles. So it requires no algebra for this question. All I have to do is plug in my numbers correctly. 125 divided by 100.08 0.09. So basically 1.25 is going to be our answer here, I think. Okay, so you get a mark for that step. Okay, effectively just using the formula properly. Okay, so we have 1.25 moles. Okay, that would be your third mark. So that would be a 3-mark question because there's really not much to that one. Okay, you don't have to do anything to the formula. All you're doing is calculating molar mass and then dividing. Okay, everybody all right with that one? Like I said, that's the easiest one because you really don't have to do much. Okay, now we did one like this next one as well on Friday, so hopefully it looks familiar. This one wants to know the mass. Okay, so what is the mass? So we can immediately say we don't know what it is. Okay, of 2.7 moles. What did they just give me? N. Of lithium phosphide. Okay, so that's going to be 6.94 times 3 plus 32.07. All right, so we're looking at 52.89 grams per mole for our molar mass. Okay, so that would be what?
Isn't phosphorus at 30.97?
Sorry, that's sulfur, isn't it?
Yeah.
Yeah. See, I got mixed up. I should really look at the periodic table. 30.97. Sorry. Which changes my number. .79. Good catch. Okay, so I have N, I have big M, molar mass, and I'm looking for mass, little m. So that means that I'm going to have to manipulate the mole equation formula so that it solves for little m. All right. So rules of algebra are, if I want to move something, do the opposite. Well, right now I want to move big M because that's how I can get little m by itself. I'm dividing by big M right now, so I'm going to multiply by big M. Okay? M over M is 1. And M times 1 is M. So that cancels. All right? That's how algebra works. Okay, and then what I do to one side, I do to the other. So I bring M over to the other side by multiplying. Everybody okay with that? Okay, so you would get a mark for manipulating the equation. Then we would have plugging in of numbers here, so we would have 51.79, our molar mass, multiplied by 2.7 moles. You get a mark for that. Okay, and so times 2.7. So we're looking at 139.83 grams. Fourth and final mark there. Okay, questions on that? The next two types of mole equation problems are going to involve you having to use Avogadro's number. Okay, because they're either going to ask you how many particles there are, or they're going to give you the number of particles and ask you to calculate the mass of that many particles. Okay, so it's going to add an extra step involving Avogadro's number. It's not going to be a hard step, it's just adding one more step. Okay, so example number 3. Hope you guys are writing these down. Okay, so example number 3 is asking how many molecules of iron 3 oxide are in 230 grams. So the question wants to know the number of molecules. Okay, it tells us the material, Fe2O3, so that'll be 55.85 times 2 plus 16 times 3. So 159.7. Okay, 159.7 grams per mole. Now that I have that, okay, they also tell me the mass. 230 grams. So I have big M and little m. How can I calculate those? I can calculate the number of moles. So even if I have no idea what to do, that should be my next step because it's the one thing I can do at this point. So if you ever get stuck on a question, look at what you have and what you can do with it. It's likely that's your next step. Okay? So our next step is plug these numbers in to the mole equation and calculate the number of moles. So I'm going to take my 230 grams. I'm going to divide it by 159.7 grams per mole and get the number of moles. Okay, so there are 1.44 moles of this stuff. Now, here's something else we need to realize. I rounded off here, but it's just because I don't want to write all those decimals because I'm lazy. Right? I'm going to keep all those decimals for any other mathematical operations I'm going to do in my calculator. Okay? Because the next thing I'm going to do is I'm going to be using Avogadro's number. Is that a big number? Yeah. If I round off a bunch of decimals and then multiply by a really big number, does that significantly change my answer? It does. So that's why I want to keep all my decimals. Okay? All right. So now I know the number of moles. That's not what the question wants. The question wants the number of molecules. So how can I use the number of moles and Avogadro's number in order to get the number of molecules? Exactly. I would multiply them together. Here's why. Remember that this number is the number of particles in 1 mole. So if I take the number of particles in 1 mole and multiply it by the number of moles, it'll tell me the number of particles. Okay? In the same way that if I said I have 1.5 dozen eggs, I would go 1.5 times 12 and find out that I have 18 eggs. Yeah, sorry, I got a couple of crooked books there. 1.5 dozen is 18. 12 plus 6. Okay? All right. Everybody okay with that? So I'm taking the number of moles, I'm multiplying by the number in a mole to get the number of particles. Okay, so that's my next step. Number of molecules equals n times Avogadro's number. Okay, so that'll be 1.44 times 6.02 times 10 to the 23. Now, entering this into your calculator, you watched the video yesterday, hopefully it made sense. But, okay, if you have a TI whatever, because there's a whole bunch of different numbers now. Started out with 83, for whatever reason, we're up to like 87 or something now, or 90. Okay, so if you got one of these, the way you enter Avogadro's number is as follows. Right, so I'd take this number first and go multiply. Then Avogadro's number always needs to be enclosed in brackets. Otherwise, your calculator tries to get smart. Okay, and it does some weird order of operations things we don't want it to do. Right, so I'm going to bracket, and then I'm going to put in 6.02, and now I want to get the times 10 to the power of 23. Easiest way to do that won't involve screwing it up, okay, is to hit the second function button, and then the comma. Okay, above the comma, you'll see that the second function for the comma is 2 capital E's. That stands for times 10 to the power of something. Right, so now I've got times 10, I just entered the power that 10 is multiplied by. Okay, so I have 6.02 E23. If you don't have a TI-83, okay, then you'll be looking for buttons that look like this. Either you'll have a button that says EXP, and that performs the same function, or you'll have a button that looks like the 2 capital E's. Okay, one or the other. Those are the buttons you want to use. So you go 6.02, and then you'd hit EXP and put in 23. Okay, or you go 6.02, hit the EE, and type in 23. Right, always in brackets. Okay, so bracket it, end the bracket. If you don't, anything you put in after the 23, your calculator thinks is part of the exponent, and that doesn't really work stuff. Okay. If you're having trouble with that, I'll come around and have a look if you have a slightly different calculator. On your phone, if you're using a calculator on your phone, I'm pretty sure the iPhone has E, okay, on it. Okay? But remember, if you're using your phone as your calculator right now, that's okay. But come unit exam day, that is so not okay. Okay? You need to beg, borrow, or creatively acquire a real calculator for exam day. I only have one, and I'm not loaning it out. Okay? Because I had a loaner, and now I don't have a loaner. Okay? I'm not loaning out my good one. So make sure you bring a calculator on exam day. You don't want to be doing mole calculations a long way. Right? Okay. So when I do that operation in my calculator, I get that there are 8.67 times 10 to the 23 molecules of calcium carbonate in 125 grams. Or 230 grams, sorry, 230 grams. Okay, so marks distribution for one like this. Again, 1 mark for gifts. Okay, you get 1 mark for this operation here. Okay, you'll get 1 mark for getting your Avogadro calculation, and 1 mark for your answer. So that would be a 4-mark question as well, because it doesn't require you to manipulate it. Questions on that one? Don't panic yet. If you didn't get that one, don't panic. There's still lots of time. Okay, last example. This one works exactly in reverse of what we just did. They give you the number of particles and want you to calculate the mass. The one we just did gave us the mass and wanted us to calculate the number of particles. So we're going to do everything backwards to do this. So writing down my givens, number of molecules. Okay, equals 5.42 times 10 to the 21. Is that more or less than 1 mole? Less. A lot less, actually. Okay. Okay. And we know that it is, we're looking for mass. And we know that the material is nickel 2 nitrate. All right, so nickel is 58.69. How many nickels are there? 1. Okay. Plus, how many nitrogens? 2. How many oxygens? 6. All right, so 182.71 grams per mole. Okay, so that's our molar mass. So what I have right now is the number of molecules and the molar mass. If I'm going to get the mass, I still need the number of moles. Okay, can I use the number of molecules and Avogadro's number to get n, the number of moles? Yes. Okay, and I would do it this way. In the last one, I took Avogadro's number and I multiplied it by n. And that gave me the number of molecules. So if I do the opposite of that, will it give me the number of moles? Yes. Okay, n will equal the number of molecules divided by Av's number. Okay, so what we have here then is 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. Right, so like we said, definitely less than a mole. Okay, like way less. All right, so I'm going to take my numbers. Both of them have to be in brackets because they're in scientific notation. Okay, does everyone know what scientific notation is? Okay, maybe let's finish this question and I'll quickly talk about what scientific notation is. Okay, 5.42, okay, E21, and I'm going to divide that by 6.02, E23. All right, So I have 0.009 moles. All right, now that I know that, can I calculate M?
Yes.
Yes. All right, so N equals little m over big M. I want to get little m by itself, so I multiply both sides by big M. Okay, and then I plug in my numbers. So M will equal 0.009 times our 182.71. Okay, and again, I've kept all of my decimals here. It's important for us to remember that. Okay, I'm keeping them all. All right, so I have 1.64 grams of this stuff. Not very much. Okay, so this would be a 5 mark question. Right, again, you get 1 for your givens. Okay, you would get 1 for calculating the number of moles. You would get 1 for manipulation of the formula. You would get 1 for your final math and for your final. All right, quick talk about what is scientific notation. Okay, scientific notation is what we use to represent either really, really big numbers or really, really small numbers without having to write all of the numbers, like all the zeros and stuff. Okay, so if I had, let's say, 1,234 as a number, and I wanted to put it in scientific notation, numbers in scientific notation are always between 0 and 9.9 repeating, so they're never bigger than 10. Okay? So I would take this number. This is where the decimal is in that number. Is everyone okay with that? Okay, so if I want to make this a number between 0 and 9.9, how many places do I need to move the decimal? 3. So 1, 2, 3. Okay, so now in scientific notation, that's 1.234 times 10 to the 3. And 10 to the 3 is 1,000, right? 1.234 times 1,000 is 1,234. Everyone okay with that? That's what scientific notation works. It works different. It works opposite with a decimal. So if I have 0.004567, okay, and I want to put that in scientific notation, I have to move the decimal 1, 2, 3 spots. Okay, so now I'm going to have 4.567 times 10 to the minus 3, because it's 1,000. Okay, 10 to the minus 3 is 1,000. So basically, it's the number of spots you move the decimal. That's the exponent that will go on the 10. If you're moving the decimal to the right, the exponent will be negative. If you're moving it to the left, okay, the exponent will be positive. Yeah? Okay. You'll learn that in math very soon. Okay. All right, I want you guys to see now if you can do this question. Okay, it's one of the ones we didn't do on Friday. It wants to know how many molecules. You can look at the example we did just a minute ago. It works exactly the same, except it's a different compound. Okay? All the steps are the same. Okay, so another one where we're going to use Avogadro's number here because we're looking for the number of molecules. Okay, we're told the mass, 600 grams, and this one works more like what you would get on a unit exam because they give you the material's name, not the material's formula. Okay, so we've got molar mass is going to be of silver nitrate, so that's AgNO3. That's an ionic compound. Nitrate's a -1, silver's a +1, so this compound is fine the way it is written. Okay, I see this one get messed up a lot. Okay, I see a lot of people who make this silver nitride instead of silver nitrate, and they are very different in terms of their mass. Okay, so you won't get the question right after that. Okay, all right, so we've got silver, which is 107.87. Yeah, mine like a steel chair. Okay. Problem is it's always closed. Means I'm closed-minded. Okay, you guys missed that one. All right, that joke flopped. Okay, and then we've got our 3 oxygen, 16 times 3. Okay. You guys are still reeling after the whole quiz prank. All right. So we have 107.87 plus 14.01 plus 48. All right, so 169.88 is what we're looking at here. Grams per mole. Okay, everybody all right with that? All right, so what can I calculate now that I have little m and big M? N, right, the number of moles. So that's the next thing I want to calculate. N equals little m over big M. So we're going to have 600 grams divided by 169.88 grams per mole. You don't have to write the units in your equation like I have been. I just do it out of habit. Okay, but you don't have to. So we'll have 600 divided by... Okay, so we got 3.53 moles. Okay, so that's our number of moles. Question wants the number of molecules. What do I do next? Multiply by Avogadro's number, because Avogadro's number is the amount of particles in 1 mole. So, number of molecules, okay, N times 6.02 times 10 to the 23, okay, which will be 3.53 times 6.02 times 10 to the 23. And again, I'm keeping all my decimals here, times Avogadro's number. So brackets, 6.02, second function, hit the comma, okay, and 23. All right, so we're looking at 2.13 times 10 to the 24. Okay, so for our purposes here, guys, we always want to round at the end to 2 decimal places. Okay, 2.13 times 10 to the 24 molecules. Questions on that one? Okay, then, like I said, there's only 4 ways I can ask these. Okay, let's try this one. It's like the 4th one I did earlier. Okay, so for number 4 here, what's the mass of 1.54 times 10 to the 25 molecules? So way more than a mole this time. Okay, it's like exponentially more. So our number of molecules is known. Okay, 1.54 times 10 to the 25. Okay, we're looking for the mass, so we're looking for little m, and they tell us that it is diphosphorus tetraiodide. Okay, so we're going to have 30.97 times 2, and then 126.9 times 4. This is a pretty heavy molecule. Okay, so 569.54 grams per mole. All right, so I have those things. If I'm going to get M, then I need to calculate the number of moles. I can calculate the number of moles by taking the number of molecules and dividing by the number of molecules in a mole. 6.02 times 10 to the 23. Okay, so that'll be 1.54 times 10 to the 25 divided by Avogadro's number. So we got to put that in brackets. So 1.54 divided by Avogadro's number. All right, so we're looking at 25.58 moles. Okay, now that I know N, now I can manipulate the mole equation to solve for little m. So I'm going to multiply both sides by big M, and that will will give me little m. So we'll have our 569. This was 569.54 times 25.58. So this can be heavy, heavy, heavy. Yeah, so it's like 14.5 kilograms, this stuff. Okay, so we'll say 14,569.63. Grams, right? Okay, is that making sense? Remember, there's only 4 ways I can ask a Mole equation question. You've seen all 4 ways twice. That's the deal.
So you're going to take marks if you like set out at like 0.62 instead of 0.63? Is that?
Well, I'm hoping that you can round.
Yeah, you can round, but like,
Yeah.
Okay.
In the same way, though, but I say that, and guys, that's a good question. Are you going to take marks off if we don't round correctly? Yes, I will, because I expect that that's something you can do. I also expect, and I'm being a little bit disappointed, that you can spell the names of elements that are on your periodic table correctly. If you don't on the test, it's going to cost you marks. Being a nice guy right now on the assignment, or not taking marks off, or not spelling the names of like magnesium and hydrogen correctly, okay? Guys, there's no excuse for that. It's on your periodic table. Copy it off of there. Okay? You make a spelling mistake on your unit exam, I will dock you marks for that. Okay? You need to copy it off of it. There's no excuse to not spell something correctly. Okay? Also, incidentally, let's go over something that's kind of important. Because I'm seeing this happen on every single assignment, except for one. Okay? When something is in its element form, what's its charge? No, when it's in its element form. It's not bonded to anything, it's just by itself as an element. Its charge is 0. Right? It's neutral. It hasn't bonded to anything. It hasn't lost or gained any electrons yet, right? So when I say you have something reacting with copper, that's copper. Not this. That implies that that's a copper ion with a charge of -1 or +1 because it's lost an electron. Copper metal is not an ion. Copper is copper. It does not require a Roman numeral. I haven't got through all of them yet, but I've only had one so far where there wasn't a Roman numeral on it, on the reactant side. When it's in a compound, then I need to put a Roman numeral on it, but not when it's in its element form. Okay? I saw that over-applied, huge, okay, on the assignment, so just reiterating. Okay, what I want you guys working on right now is some of the Mole equation stuff out of the digital workbook here. So if you go to Google Classroom, under classwork, okay, chemistry notes and workbook package is where you want to go. And this is the key for the Mole equation worksheets. Okay, so the PDF document here in the top right. But obviously you don't want to be looking at that until you've tried a few of them. Right? So you want to go to the digital workbook file, which is the bottom right. Okay, and near the end, you will find a worksheet entitled the Mole Concept Worksheet. I will show you a video explaining why it is called the Mole Equation Worksheet in a little bit to give you a little break. But what I want you to do right now is I want you working on questions 2 and on. Okay, so question number 2 is basically like the first Mole equation problem we went over. Question number 3 is like the second one, and so on until it kind of goes like that. Okay, so give those a try. Okay, see how you do. You can check the key, see if you're doing them right. Okay, if you have questions, then I'll have to go over them. Okay, but for now, let's have a little practice time, and in a few minutes, I will go over why it's called the Mole equation worksheet. All right.